The next thing that we need to talk about is how to graph solution sets for linear inequalities. The first video I posted talked about graphing solutions for linear equalities. Those are just plain old lines. But when we want to graph the solutions to linear inequalities, we want to shade a portion of the XY coordinate plane. Let's get started. I'm going to use something similar to the line that we saw last time. Except this time, instead of saying y is equal to x, I'm going to say y is greater than x, and we'll see what happens. Now, the best way to get started actually might be just to go ahead and graph the line y is equal to x. So I'm going to write that in blue. We're going to think of y is equal to x. And we'll just go ahead and graph that like we did last time. We'll make a t-table for x and y. We'll plug in, let's say, x is equal to 3 and x is equal to 0. And we'll figure out what y is for each of those x values to come up with 2 points for our line. Okay? So if x is equal to 3, take this and plug it in. That would mean y is also equal to 3. Agreed? And if x is equal to 0, let's plug that in. So x is 0. Well, then y would be 0 as well. So now, these entries in the t-table, the 3, 3, and the 0, 0, they correspond to points in the xy coordinate plane. This point is the point 3, 3. And this one represents the point 0, 0. Now we're ready to go ahead and just graph a line, okay? So let's see, that first point is the point 3, 3. So we walk over 3, we walk up 3, and the point would probably be about there. The second point, 0, 0, that's the origin, right there. So let's draw a line. And this graph approximately represents the linear equality, the line, y is equal to x. All right, let's go back to the inequality, because that's our ultimate goal, is to graph the solution set for the linear inequality. Okay. Well, here we have y is strictly greater than x. Now, as you recall, on Thursday we talked about these things. And we said that if we had a strict inequality, that means no potential for equals to, then we would want a dashed line. I'm just going to take my eraser and I'm going to erase portions of this line so that it's dashed. All right, I think that pretty clearly shows that the line is dashed now. Okay? Well then, as we did on Thursday, we're going to shade a portion of the Cartesian plane. But we just need to figure out which portion we need to shade. Now, a good way to deal with this is to select a test point. And the test point is going to be any single point in the Cartesian plane that is not exactly on this line. So, I don't know what you want to choose. Maybe I'll choose this point. This point here, which is the point 0, 3. Now, with the test point, you take that information, you take x is equal to 0, you take y is equal to 3, and you plug it into this inequality. All right? So if I were to do that, I would have 3 over here, I would have 0 over here, and I would want to check whether or not my statement is true. So is it true that 3 is greater than 0? Yeah, absolutely it is. Well, that tells me that the part of the Cartesian plane that I need to shade is the part that contains that point 0, 3. In other words, I need to shade here. And that represents my solution. Is this whole shaded portion. So this whole part of the Cartesian plane is shaded and this whole part is not. And I need that dashed line there to represent this inequality, okay? And there you go. Now, if you would have chosen a different test point, like let's say instead we choose the point 3, 0. Well, you do the same thing. You take the test point and you plug it into your original inequality. I'll do that now. So let's see, I would take the 3 and put it where x used to be. And I would take the 0 and put it where y used to be. And make sure that I write my little inequality symbol as well. Again, I check the truth value of this. Is it true that 0 is greater than 3? No, it isn't. So that's how I know that I don't shade this part, because I know that this point is not part of my solution set. I know that I have to shade the other part on the other side of that line. And that's really all it is to graphing a single linear inequality. So I hope that helps. I'm going to make one more video. I'll see you in a bit.